Hello everyone, I am Maurizio, editor-in-chief of Power Electronics News. I am at PCIM and I have the pleasure to stay here with Doug Bale, Vice President Marketing and Applications Engineering at Power Integrations. Hi Doug, how are you?
Hi, nice to see you.
Nice to see you. So we are at PCIM, one of the most important conference of power electronics. How is it going? How Power Integrations is showing? What is you are introducing?
Well, firstly, it's always a pleasure to be here at PCIM. It's extremely busy. The show floor has been full. Our staff have been running off their feet with opportunities today. What we've launched at the show is we have a new module driver for IGBT modules and silicon carbide modules. The benefit of that particular driver is data telemetry. Particularly temperature. So a lot of modules have an NTC readout, but it's important to the users, especially for very, very high voltage modules, 1700 volt, 2300 volt modules, 3300 volt modules, to be able to get an isolated data stream back from the module that's reliable, doesn't have a lot of common mode noise problems. And so what we've got is this is a new module driver that includes this telemetry feature, so people can do a better job of understanding, managing, and controlling their modules.
So let's understand trends, developments for power electronics. What's news? What's new trends and developments? So are you seeing in the field of power electronics? Maybe focusing on specific markets such as automotive and consumers.
Well, I think it's got to be wide bandgap. I mean, everybody is we've been talking about wide bandgap for a few years, but it's still the trend, right? It's still where everybody wants to make their developments and differentiation. For automotive, I think silicon carbide is the key, and for that we're working with the driver technology. We have a product called Scale EV, which is a board level product. It's automotive qualified, it's ASIL ready, which is unique, and that can drive Econo dual modules, it can drive a hybrid pack, the road pack module, and so that's very good for driving silicon carbide in the automotive application. It's particularly good for bus and truck and construction, agriculture equipment. It's probably a little bit of overkill for passenger cars. And then for the consumer products, it's all GaN, right? GaN everywhere. We've found a wonderful market for GaN in these aftermarket adapters, particularly manufactured out of China for notebook and cell phone chargers. You can make a very, very tiny adapter using our technology. We've introduced a power factor corrector, and that's the first power factor corrector product out there with integrated GaN, as well as a product we call MiniCap, which is great for making less than 65 watt adapters very tiny. And then we've got the flybacks and the active clamp flyback, regular quasi-resonant flyback, also incorporating a GaN transistor.
So you mentioned GaN, you mentioned wideband gap. Let's see the progress of gallium nitride. So which is the recent progress of GaN that you would highlight, you would put in evidence? Maybe you may mention the recent project or case study where GaN is played or is playing an important role in terms of performance efficiency.
Right. So the rule that we follow at Power Integrations is that if GaN can do something, it should do something, because it's better and it's cheaper than any other way of doing it. It's better than silicon, and it's cheaper than silicon carbide. So if you have the opportunity to deploy GaN, you should. And usually that's a limit of voltage. So we've been working very hard to get the voltage level up on our GaN. And we've launched an automotive qualified 900 volt GaN device for 12 volt replacement in automobiles. So EVs, you have a wonderful big source of energy, the big battery, and but the old technology is 12 volts. Well, the right thing to do is really to get rid of that 12 volt battery and replace it with little power supplies so that you can you know, provide energy to all the small applications, the lighting systems, the seat heaters, the navigation systems, electrical systems, pretty much anything that needs power. It's really better to do it with a power converter than cart around a lead acid 12-volt battery. So that's what we're using the 900-volt GaN for, and that's for 400-volt systems. And you can bet that we have our eye on 800-volt systems, and that's going to require a 1200-volt GaN, and that's the next stop. We're not there yet, but we're very confident we're going to get there.
Good. So when you are evaluating GaN, maybe the question that would emerge is which is the best solutions for that application? I mean, talking about GaN on silicon or GaN on silicon carbide. Maybe this is for RF market, or GaN on sapphire, or GaN on GaN, because GaN on GaN is a vertical structure. Maybe this is not for now, maybe in the future. I don't know what you think about vertical GaN. But which is your point of view for the substrate? And talking about reliability, this is a big topic. How do you assess the reliability in this case?
So we committed to GaN on sapphire when we first started down this path, and we're very happy with our choice. The GaN on silicon is a lot more technologically difficult, and we don't think it gives you such a good outcome. The fundamental difference is whether it's a compressive or tensile stress on the GaN. And it turns out that sapphire gives you a slight compressive stress, and that because of the lattice mismatch. And that leads to a more homogeneous film with fewer dislocations and inclusions. The problem with silicon is the stress is tensile, and that means that if a crack forms, it's very hard to fill it in. The bottom line is you need thicker epi, you need more buffer layers, you need a lot more technology to get a worse outcome. Whereas our GaN on sapphire is fabulous, it's low leakage, it's capable of very high voltages, and so we're very comfortable with the choice that we made, and we think it's the best choice.
Do you believe in vertical GaN?
Sure I do. It's not a technology that we participated in. I think it's still a little bit science project world at the moment because of the costs involved, but I think eventually the industry will get there.
Thank you, Dag. Thanks a lot for your time.
You're welcome. Nice to see you.
Thank you, and stay tuned on our channel, powerelectronicsnews.com, for the latest updates. Thank you.